Hello, my name is Stephanie, and today my group and I are going to talk to you guys about how the Earth rotates around the Sun. This is Adam, Brian, and Baruch.
My name is Adam. I'll be going over a brief history of what people believe the Earth looked like prior to 6th century BC. Now, imagine what it's like to live on Earth during prior to 6th century BC. Knowledge was scarce, and only the wealthy had access to education. But even among the very few who were educated, they believed that the Earth was flat. In ancient Mesopotamia and Egypt, it was believed that the Earth was a disk floating in the ocean. Now, it wasn't until roughly about during the 5th century BC, where a Greek philosopher by the name of Pythagoras introduced the concept of Earth being a sphere rather than being flat. But even though after he proposed this theory, it was only a speculation until the 4th century, when philosophers combined Pythagoras' concept of a spherical Earth with Plato and Aristotle's concept of the world revolving around the Earth, which was called geocentrism, which is essentially that the planets, the stars, and the sun all revolve around the Earth, and the Earth is at the center of the universe. And this geocentric model would be the standard belief of what the world looks like until the mid-1650s.
Okay, so I covered what are the effects when the Earth rotates around the Sun. So basically, as the Earth is rotating around the Sun, it's also moving. It takes the Earth 24 hours to rotate around its axis. The path that the Earth takes as it's moving around the Sun is called its orbit, and the amount of time it takes the Earth to completely orbit the Sun is 365.25 days. An axis is basically an imaginary line that goes through the north and the south pole of Earth. Why do the planets and the Earth orbit around the Sun?
Hi, I'm Brooke. So the reason why does Earth and other planets revolve around the Sun? To understand this phenomenon, it takes few facts to understand. So we have to know how matter behaves in a space-time. So to illustrate the fact, we have let's assume a space as a sheet of rubber, right? So this is our space. Here we can see that whenever we put matter on our space, it bends it. So when a matter bends time-space, and whenever it bends something, two matters, they kind of attracts together. So if we have two matter which are heavier and lighter, the heavier matter will attract the lighter one. So that's how actually the Earth rotates the Sun. So here we can see that we have a heavier matter over there, so it's bending our space. So if we let other lighter objects if we give them an initial speed, they kind of rotate around it. So it kind of attracts those lighter objects. That's how the Sun attracts the planets and including other matters in our solar system. So why does if it's attracting our Earth, why not consuming it? So the thing is, in our space we don't lose energy. So whenever in space, like our Earth has a constant velocity, that will never lose any energy. So it will just keep spinning around the Sun. So that's the reason.
So now I'm going to introduce the Gregorian calendar and how it's pretty much connected to how the Earth revolves around the Sun. So in 1582, Pope Gregory VIII declared that 10 days starting from October 4th to October 15th, that simply those days wouldn't exist. And then starting on October 15th, that's when the Gregorian calendar pretty much would start being used. And pretty much he introduced this calendar to pretty much replace the old Roman calendar, which was pretty much completely inaccurate.
Say pretty much one more time.
The calendar was really inaccurate over the time, over years, pretty much. The seasons would be completely out of alignment from actual true year. The Gregorian calendar only displays 365 exact days for a year. The true exact year is actually 365.2429 years. So over time, if you add that time up, that means in 100 years, our Gregorian calendar is actually behind the true scientific year by 25 days. So that's when the leap date was created. The leap date was created so we could use those days that we were behind using the Gregorian calendar to catch up to the real scientific year. Every 3 years, we are behind every year the Gregorian calendar by 5.8 hours. What we do is for 4 years, we collect those, I would explain as hungover time. That would equal to 24 hours, equaling to 1 day over 4 years. And we've been using it ever since for a little bit over 400 years. And I have a couple illustrations to pretty much explain this. So we have our 4 years right here. Each year has 5.8 hours. We ignore those 5.8 hours and we just save them. So if you look down here, on our 4th year, we collect those hours that we collected and saved, and we just include it right here at the end of February, which makes up our leap day. We use the leap day every 4 years, or any year that's divisible by 4, we use that leap year to catch up to the actual scientific year.
Every year that's divisible by 4?
What was that?
What was that last statement? That sounded like bad math. Say it again.
Oh, every 4 years we include a leap year.
Uh-huh.
So,
And? What else did you say?
oh, yeah, I said we were behind by 5.8 hours every year.
Okay.
So over 4 years, each 5.8 hours from each year, we save and it collects to pretty much 24 hours. So that's, we add it to the end of February 29th on the 4th year to catch up back to the actual scientific year.
Continue.
Okay, so this is just an index giving credit to all of my team members and what we worked on.
Questions?
Andy? You raise your hand.
Louder.
So it's just that we're also covering calendars. Yeah, it's okay.
Questions on the subject matter?
It must be clear.
Is the geocentric way of thinking completely eradicated?
Yeah, in the 1600s, heliocentrism took flight over geocentrism. It was essentially that belief that everything in the solar system orbits around the sun rather than everything revolving around the Earth. So yeah, now it's heliocentrism.
That concept is geographically unique to Europe in those times. So you did have Chinese calendars with different mathematics and science that were far more accurate. You also had Mesoamerican calendars that were way more accurate in those times. So that should be noted.
Any other questions?
Okay.